let me introduce who we are as a company. So again, it's GasQuip. We are a 5-year-old company. We started GasQuip back in 2020 during the pandemic with really just the goal in mind of helping electrical utilities with all sorts of needs, but we really focused in on the SF₆ gas handling, analysis, leak detection, sectors of our solutions, and started doing trainings and going out and meeting with customers, really just seeing what items and products that they would like to have and would be necessary for them, and try to fill some gaps in the market. So, like I said, we've been around 5 years. We recently got on the Inc. 5000 list for fastest growing companies in the US. So we're very proud about that. And we're about to have our 5-year anniversary this month. So a lot of good things happening with GasQuip and some new faces. Also, if you've been following us for a while, some new hires and new faces and new partners around the world. So very excited for things to come. So, like I mentioned, we handle mostly SF₆ gas analysis, leak detection, repairing leaks, helping customers with trainings, and doing webinars like this that are informational. So gas analyzers, gas leak detectors, little sniffers, scales, mass measurement. We have a little mass flow meter, really anything that has to do with the gas moving in and out of the breaker, the fittings, adapter kits, as you can see there, is stuff that we handle and touch and help with customers. So let's just jump right into it. Why do we test SF₆ gas? I've heard this answer before because my boss said so. Not a great start, not a great answer. That's not true. There is a reason why we do things. And because my boss said so is not a great answer. So really it comes down to preventative maintenance and safety. So preventative maintenance on the gas insulated equipment side, we are trying to extend the life of the equipment that the gas is inside of. And we follow both IEC or ASTM or all these different standards and guidelines that are set by people much, much smarter than us, to try to help us maintain our equipment, and then also the recommendations provided by the breaker manufacturers to help extend the life of the equipment, keep it up and running, and get a return on our investment, of course. So the other part of it is safety. So we want to make sure that we are keeping our guys out in the field safe from some of the harmful things that can be found in the gas, and make sure that we are following the right guidelines on that to keep everyone safe. So those are really the two big reasons that we test SF₆ gas. And here's kind of the internals of what goes on inside of a breaker. You can see that there's a lot of heat generated, a lot of energy inside of these breakers. And when you mix gas, moisture, different contaminants, it's really just a petri dish of things that can come out of all of those equations and chemistry. So we'll talk about some of the common things that we test for today, and then keep going from there. Grab some water. All right. So why do we test for SF₆ percentage or purity? Well, it really has to do with more about the properties associated with why we use SF₆ in the first place. So the way I like to think about it is, if you're going to go get a health checkup at the doctor, they will be testing your blood for contaminants, different particulates that might be because you had a Big Mac cheeseburger the other day, and the cholesterol and the things floating around your blood that can be indicative of what's to come. And that will give you an idea of what to expect, how your body will perform in the future. The same idea can be applied for SF₆ gas in a roundabout way. We are measuring different things inside of the gas, for this example, SF₆ purity, to make sure that it can perform to what it was originally designed to do. And one of those things is the dielectric strength, another being its arc quenching ability, and the third being its heat transfer capabilities. So if you have up to a certain point amount of pure SF₆ gas in the breaker or the gas insulated equipment, you can expect to have that gas perform to the level it was intended. As soon as it falls below that threshold, we can't guarantee that it will perform these different duties that it's supposed to perform. So that's why we test SF₆ purity. Now, why do we test for H2O? So really comes down to one main thing, but two things. It's a fuel source for arc byproducts. So when you mix SF₆ gas and moisture, H2O, and heat, that can create a combination of different compounds and molecules that can be very acidic. Like we'll touch on today, SO2 or sulfur dioxide can be very acidic and harmful, both to the breaker and to the operators that'll be moving the gas in and out of those breakers. So that's really the main reason that we test for H2O. The other one being that at very high levels, and we're talking over 1,000 ppmv, it can impact the insulation performance of the insulators on the breakers. But it's really at the high end. Most of the time, we're testing because we want to try to prevent the arc byproducts from forming. And this is the SO2. So SO2 is a very acidic compound, and it's comes as a result of the SF₆, H2O, and energy mixing all together. So it's very acidic and corrosive to the equipment, can wear down on the nozzles, on the contacts of the breakers, and also for the actual people that are moving the gas in and out, like we talked about, it poses a great health risk. If you are going to be performing internal maintenance on a breaker, you need to pull that gas in and out, or you're trying to get in and clean out the breaker, vacuum it, decommission it. You need to have certain levels of, HEPA filtration and PPE and respiration so that you're not breathing in these very acidic, bad compounds. And what I tell people is if you ever smelled like a rotten egg smell coming from a breaker or when you're dealing with the gas, it's probably a bad sign. You're probably smelling that sulfur dioxide, and it's a good sign to go get the right PPE. And we can help you figure out what you need to do in those situations. But that's why we test for SO2. So let's talk about some of the limits that we have set for when we actually test the gas. So for the SF₆ purity, we have a in-service recommendation from IEC that is above 97%. So anything below that would be considered, red light. It's time to take action, whether that means pulling the gas all the way out and refilling with pure SF₆ that's above that 97%. Really, these recommendations are what I like to look at them as a go or a no-go value, where if you fall below a certain purity percent or exceed a certain moisture percent, it tells you that you need to take some type of action. So for SF₆ purity, that is 97%. That's the IEC recommendation on that. On new bottles, we have above 98.5%, and that is also IEC recommendation. For H2O, for in-service GIE, another IEC recommendation of below 200 ppmv, which is about -36 degrees C at atmosphere for dew point. And then for new bottles, this can trick up people sometimes. For new bottles, you may have noticed when you've gotten a bottle from a vendor and it has a certificate of all the different values that were measured in the factory, and it might say below, 7 ppmv moisture. Well, that measurement was actually taken at liquid phase of the gas at the factory and actually applies to a different standard that is the ASTM standard that's for new virgin bottles of gas. And whenever you get it at your facility, your testing bottle, you're probably not going to get that really low 7 ppmv because you're testing the headspace or the gaseous compartment on top of the bottle as the bottle stands up. You're testing that gas on top of the bottle. And that's actually a different, what you can expect a different result when you're testing that. So something to be mindful of, but the actual recommendation from IEC on new bottles is below 200 ppmv. So good to know. We have SO2. So for in-service GIE, this is also can be kind of surprising to some people. This is the IEC recommendation. I know that Internationally, it's kind of a mixed bag on what people do as far as when they see SO2 in their systems. I know in certain areas, like in Singapore, that it can go as low as like a few parts per million of SO2, and they take action. For IEC, it is 500 for in-service GIE, and then for new bottles, it is also recommended for 7 ppmv on the new bottles. So more than people actually might think from the conversations that I've had, people are actually kind of surprised by those recommendations sometimes because most bottles come at 0 ppmv SO2, but technically speaking, if it was showing a few ppmv of SO2, it's fine according to the regulations. People smarter than us. Okay, so let's go back here. I'm going to go to full scene. So let's talk about what to expect when you open up an analyzer. We'll talk mostly about the Flex today, but normally you would have a lid here, pull that open. On one of the pouches, you have power cord and a sample hose. So we have a braided stainless steel Teflon hose. Plug in the cable into the device and turn it on, and then hook up your hose using a quick connect fitting that's on the end of the hose. It just attaches to that. If you are dealing with a high pressure in the hose, you can pull back the collar on the front of that fitting and then stick it in. It goes in a little bit easier. So that's what to expect. And then normally we would have a pouch over here on the lid, has your CAL certificates and your manual, and then a USB stick and a torque wrench. Down here we have fittings to adapt our sample hose to a breaker. So this is a DN8 female by Rectus Type 21 Quick Connect. And we have the same setup for DN20. I can pull this up. So this is the same setup for DN20. Again, has that Rectus male that goes onto the end of the sample hose, and then a DN20. Here on the left side, we have, for our analyzer, we have something unique. It's these sensor modules. So each individual sensor that measures an individual thing is stored inside of each of these sensor modules. And here's kind of what that looks like. So little plastic box. I tell people it's kind of like a printer cartridge where you can pop it in and out, and it's quick and easy. You don't have to mess with a lot of stuff. But you can see on the bottom of this, if I can get that to focus, there's a inlet and an outlet, and the sensor sits on the base of this module. And then there's some computer boards and other things inside of there. But it's just an easy way for calibration to not have to send your device back to the manufacturer, especially internationally. This is a big problem that we heard when we first started development of the device, that it takes forever, sometimes weeks, months to get a device to and from the manufacturer for calibration. You don't know what's going on. You're not getting a lot of communication. So for us, we decided to take a more modular route with these sensor modules so that we can send you the new modules. You pop out the old one, pop in the new one, and you're good to go. There's no other extra steps besides recycling the modules, send them back to us. But it makes that process down from potentially a few months down to less than a minute to swap out a couple modules. So it's pretty nice. Like I mentioned earlier, we have the sample hose port here, and then we have an auxiliary storage port here. It's the inverse. It's a male Rectus Type 21. So that can be hooked up to a bag for external gas storage. We have a gas recovery bag that has a certain size and everything to it. You can also hook up an empty bottle if it is below 150 psi. Really just want like a fully evacuated empty bottle if you're going to hook it up to the auxiliary storage. Obviously the big screen here, and then we have a couple ports, communication ports, and then a USB port. Right now I have a USB mouse hooked up to it so I can control it, but you could hook up a USB stick for firmware updates or also to export files to like a CSV file. So run a test, go to the logs, and then you can export it onto a USB stick. It's just a really simple standard file. You don't need any special programming or programs to open the file. It's just a Excel file or a dot text file. whenever it pulls up on your computer so that it's nice and easy to get your information over to a different computer. Over here, you have a gas. Oh, that was really getting out of focus. Gas recovery bag. So this is where the internal storage is stored. It's about a football-sized bag that sits underneath this panel, and that will expand and contract as it's filled up or evacuated. And for most analyzers, they sit kind of up underneath the bottom of the analyzer. Ours is off to the right, so you can actually access it. If something catastrophic goes wrong, we have the ability for you to actually go in and replace it or, access it if need be. So it's a nice little touch. Um, Now that we've kind of talked about a little bit of the mechanical, what to expect on the analyzer, we can look at the inner workings of the software. So here on the right side of the screen, if I can get my mouse to wake up. Let's see. 1 second. Okay. So here on the right side of the screen, we have our input pressure coming in from our sample hose, and then we have a storage percent. So that's our internal storage. If you were to unchecking that means that you're just dealing with the internal storage of the unit. If you did hook up a gas recovery bag, you could check this, and then that will grant you extra storage to fill up in that storage percent readout. Up here, we have our time. We have some functions. So the pump back function used to pump the internal gas that you have stored or from a gas recovery bag back into the breaker that you're testing or back into like an empty bottle that you want to put the gas in. We have a evacuate hose, which is used a lot. This is the first step in any test that you're going to run to clear out the hose of any gas that might be trapped in there, residual gas. Evacuate hose function that dumps any gas you have in your bag to atmosphere. Really nice if you're doing like a nitrogen flush and you need to dump that gas to atmosphere. A leak check, which pulls a leak, or sorry, it pulls a vacuum on all the internal plumbing and then also the modules on the left side. It pulls a vacuum on those and it holds that vacuum for a second to see if there's a certain amount of rise in pressure, checking for leaks to make sure everything's tight. Here on the bottom, we have our dry system function, which is nice if, say, you've set your analyzer outside on a shelf for 6 months or something, and moisture has started to kind of creep into the unit, and it's testing maybe higher in moisture than you expect it to. You can run that dry system function, and that will pull a vacuum on all the major internal plumbing components and try to, again, flush out some of that residual moisture in there. So that's nice to have. Some water. Of course, down here on the right, we have our play button to actually start a test. And then here on the left main part of the screen is the individual modules. So we have our SO2 module, the units here in the top left, and then it'll show selected. If it's selected, meaning it's going to be run as part of the test, you can deselect that or select that. And as you have more modules installed, you can scroll down on this list to show all the modules that you have installed. We have up to 9 slots on this particular analyzer. And the reason that we did that was really 2 reasons. One, for redundancy, and then 2, for future things that are coming out to replace SF₆ gas, because SF₆ is being phased out in certain parts of the world right now for SF₆ alternative types of gases. And some of those are like Novec type gases, the G cubed gases from GE, and some of the others. Right now, we're focusing on the dry air vacuum style breakers because we think those are catching on quite a bit here in the States. So we have a O2 module that we'll be releasing soon that'll be able to measure the purity of the nitrogen oxygen mix for those dry air. It's dry air, ultra air, pure air, whatever they call it, gas mixtures. And then also you can use your H2O module for that as well. So we can test different types of gases, trying to keep it modular and easy to use. Excuse me. We can look at the settings So here in the main settings, we have system settings, some different units that you can change, time. Here on the bag, if you had a different gas recovery bag from a different manufacturer, you could change the liters, excuse me, that capacity, just in case it's different from ours. Ours is default 52 because that's what our gas recovery bag is. The date and time, displayed units. This gas type mixture is kind of what I was just talking about, where you can use the device on different things. So SF6 and CF4 is good for SF6 and CF4 mixtures. And then if you go back to the home screen, it'll actually have a different readout. So it'll give you the percentage of that particular mixture. And we'll be adding more of those as we go along and develop new sensors. So the mixture SF6 N2, O2 N2, right now we'll just leave it on SF6. Got the serial number of the Flex, the overall unit, the firmware version, brightness, and then if you were going to update the firmware, you just click that and plug in a USB stick. Going back to this screen, so we have some advanced settings locked out on the user login thing that we can access if you're having trouble. There's a log area for all the logged files and tests that you've run, and you can export those, like I said, to a USB stick or delete them out of there. Here we have the module settings. So for whatever module is actually plugged in, you can go in here and access the information for each module. So this is the cal date, the date it was calibrated on, the cal expiration date, and then a version number and serial number for that respectively. So not too bad on that. In here, we have our test limits. Let me actually make this a bit bigger. There we go. So we have our test limits for SO2, SF6, H2O, all the different modules that are actually connected. And you can create and change those test limits based on, you might be using, the IEC ratings that we went over earlier, or you could have your own regulations for your own utility that you guys use internally. So it's nice. You can go in and change that for each unit and it'll save that information. So what those do, it gives the user an idea of whether or not their test met the criteria for what they're actually testing. So when we actually run a test, this box will turn green or red, depending on whether or not it met the criteria that you had set in the test limits. And it's just really a way to know quickly whether or not the gas that we're testing hit what we're trying to hit. So we can run a test real quick and I'll show you kind of the setup that we're going to roll with. So I've got a bottle of gas over here and purposely picked one out that was not super pure, but it should be dry and we're going to run a test on it. What we can do first is pull a evac hose on our hose. So in order to do that, you would first connect up your sample hose here at the front. Don't connect it up to the breaker or to the bottle in this case yet. Otherwise, you'll just be dumping gas out. So we're going to run an evac hose on that. So if we go back to our screen here, we're going to run evac hose. So it's asking, are you sure you want to evac hose? Please confirm there's no vessel connected or you'll pump all your gas to atmosphere. Very important. So before I do that, actually, input pressure here showing about 7 PSI. After we run this evac hose, it should be down to a vacuum and that vacuum should be holding. So this evac hose function will run. This also checks for leaks. So it'll run the evac hose. You may or may not be able to actually hear the pump running right now, but it runs the evacuating hose function and then it'll hold the function until it sees that the pressure isn't rising past a certain point, and it'll tell you that your hose has no leaks. So this is the way to actually check your hose for leaks. Sometimes they can get kinked up or stepped on or broken, and this is the way to actually check that. So once this is done running, it'll give you a check mark if it's passed or an X if it did not pass and that vacuum is not holding. For us, it looks like we passed. Evacuate hose is complete. So we'll dismiss that and go back to our input pressure here. This is holding at about -12.3 to 4. That's what you want to see when you actually run that evac hose function, is that this pressure is not moving, and you would fail if it was. So we can run a test. So let's go back to our full scene, and I'm going to hook up a bottle of gas. So we have our regulator hooked up over there. I'm going to go around the back, and we're going to apply about 40 pounds of pressure to the inlet of the machine. It doesn't really matter as long as you're at 5 psi and you have good flow from the regulator or breaker that you're testing. And we'll start a test up from there. So once we have a regulator actually hooked up nice and tight, we're going to open the regulator counterclockwise, and we have pressure on the input side, and we're going to increase pressure on the regulator. Again, I'm going to go up to about 40 psi. You can see that needle moving as I turn the regulator clockwise. And then we'll take our hose, connect it up there. And if you notice, back on our analyzer, the pressure has now jumped to 38.77, so about that 40 psi I was shooting for. So we've got gas hooked up, all the valves are open, and we can go ahead and run a test. So let's go back to close up. And we've got zero storage, everything's evacuated. I'm going to uncheck this since we have no external storage hooked up currently, and we'll go ahead and run a test. I'm going to uncheck SO2 just for sake of time. And we can go ahead and run a test. Now let's talk about what we're seeing on this screen. So as the test actually runs, you have a live reading or readout here on the bottom. For any modules like the SO2 that's disabled, we have this disabled. It still shows what it is, but the progress bar here tells you how much time you have left, and then live readout. Next to the live readout, you have a accuracy of the actual sensor. So this is a infrared sensor that has an accuracy of plus or minus 0.5%. And excuse me, we have that just so that you know whenever you're testing what to expect from the performance of the sensor. So if you are testing pure SF₆, which we're not right now, you would expect to see at least, if it was 100%, you would expect to see at least 99.5% purity of SF₆ on your readout. Same thing for moisture, H2O. The accuracy is given in a degrees C at atmosphere, because that's what the sensors actually come calibrated under, is that degrees C at atmosphere. So we can toggle those units to different types of units that we want to see. And I usually just use ppm because it's easier. So what I mentioned before about the sensor test limits that we had set. So we had set earlier a 97%, at least 97% test limit. Because we're underneath that, this whole module has turned red. We have this big X to let us know, hey, this gas is not good to be used for multiple of different things, but for the test limit that we set, it didn't meet the criteria, so that has turned red and let us know that we have exceeded the limit that we set. Down here in the bottom left, we have our time remaining on the test. And then up top, we have the enable auto pump back. So if I click that, that'll enable a pump back function that can run in the background as the test results show. And that all that does is really save some time so that you can start the pump back function as you're reading through the results of the test. If you need to stop the test at any time, you can just click the pause button, and that would stop the test and return you back to the home screen. And no problems there. It just shuts off the test and you're good to go. So we'll let this run for a sec and then see what our results are. And I can kind of show you what the result screen looks like and how to save a test. And I have seen a few questions coming through, so we should have some time to touch on those at the end, but hopefully those are getting answered in the chat. I'm going to disable auto pump back right now. Since we're testing on a regulator, the gas can't be pushed back into the cylinder for two reasons. One, a regulator has a check valve on it, so we're not going to be able to push that gas back into the bottle through the regulator. And two, the gas cylinder that we're testing off of has a pressure of about 300 psi. And so we can only pump back because we have a small pump in our unit that can only pump up to 150 psi. So we wouldn't be able to force that gas back into that cylinder anyway. So something mindful to be to know. Our H2O usually starts out pretty dry and then rises a little bit and then it'll level out. The reason that is because we have a built-in sensor heater on the tip of our H2O module. It's kind of a unique function from the sensor that we use and what we went with. That helps to kind of burn off some of the residual moisture trapped inside of the module, inside of the plumbing on the inlet side of the manifold. And it tends to level out like you're seeing here back to where it should be. Okay. Cool. I was hoping we get these results. So here we have, again, the green box telling us, hey, we've passed for our H2O. We have a big check mark here. And then our test limits indicates that we are below the negative 36 degrees C at atmosphere or 200 ppmb, same thing that we set earlier in our test limits window. And then for SF₆, we failed. So we have a big red box and it's giving us a below 97% test limit that we set earlier. Over here on the right, we have our different information that you can fill out and add. If you needed to add some additional notes, you can add those in here and those will save. If you need to rename the full name of the test, then you can. The default is the date plus the time and then the serial number of the device, but we could go in here and rename that to whatever we wanted. And that will save on the actual test. So then we can either delete, rename, or save from this window. So we're going to save this result. Now it's telling us log successfully saved. Would you like to pump back? Now, like I mentioned earlier, we are testing off of a regulator, so we're not going to be able to pump the gas back. So we're going to have to keep it in internal storage for now until we can move it to an empty bottle. So we're going to say no. And it's going to take us back to our home screen. So again, now you can see that our storage has jumped up to 27%. And here's actually a good visual. If we did plug in a auxiliary storage bag, that would change based on what we had earlier. And so we got our system, user, test limits. I think I've covered all the stuff on there. Down here is a kind of a disclaimer software license for some of the stuff we use. Let me go back into the full scene and our PowerPoint. How are we doing on time? 12:36. Okay. So let's go back into our PowerPoint and talk about some of the most common analyzer problems. So normally when we get calls, or just from what we've heard in the industry in general with any analyzer, some of the most common problems start out with, hey, I'm not getting the results that I'm expecting. Most commonly it's, hey, H2O is higher than expected. Well, what are you expecting? And also, how can you verify that what you're expecting to get is actually the true value of what you are trying to test? So if you're testing a breaker and you expected that breaker to test, at a certain, say, 150 parts per million volume of H2O, and it didn't, do you know for sure that breaker is supposed to be a much lower or higher amount? Or are you just basing it on a different analyzer? So it's really hard sometimes to verify for sure the gas that you're testing is what it says it is, The easiest way that I found is to use verification gases. We sell these. You can get these from any kind of gas vendor. They come with a certificate, especially if you're dealing with like pure SF₆. It'll come with a certificate of X amount of purity and X amount of H2O, and you know for sure that this gas that you're testing is what it says it is. But it's important to have a benchmark of what you're testing, plus also the actual accuracy of the sensor, how that plays into the measurement you're seeing, because you might be getting, 195 ppmv, and you're thinking, oh, I thought I was going to fail. I thought I was going to be at 205. Well, in reality, that's kind of in the ballpark of where the sensor accuracy actually sits. So it may not be as bad or as good as you thought. So it's just important to look at all the little details when you're considering, is this test actually both precise and accurate? For H2O being higher than expected, typically what I'll recommend is to run a dry system function on our analyzer. Try to pull out some of that residual moisture that might be sitting inside of the unit, especially if you've tested semi-wet gas recently. You can flush the unit with nitrogen. Nitrogen that comes from a normal gas vendor is going to be extremely dry. It'll help pull out some of that moisture. You can also run a leak check to make sure that your internal plumbing and modules aren't leaking. You can take your torque wrench that's provided and tighten down until you hear a click on all your modules to make sure that those are tight, because the seals on the bottom of those have to be tightened down to a specific torque. And then you can also run a evacuate hose function, which will check for leaks on your hose. That's where I would generally start on H2O. And then there's some general gas handling best practices, such as never use a regulator that has like a rubber diaphragm. Really, if you have rubber anywhere in the system while you're testing, you can expect to have higher moisture than you should, since rubber is very permeable and will allow moisture to absorb and adsorb in between the rubber. So rubber's a no-go. Always use Teflon or a stainless steel Teflon braided hose. Try to have a dry regulator that you keep off to the side in a nice, dry, controlled environment. If you just have it one out, outside on your truck, that's been open up to the outside elements, it's probably going to be reading a little bit wetter on the first pass that you have. So be mindful of what touches the gas before it actually gets to the sensor. Again, too, on the ends of the fittings, try to keep your hands off the ends of the fittings. We got sweaty hands out there. So that moisture can kind of build up inside the fittings, on tops of the fittings. Try to keep those nice and clean, and that generally will solve most of the issues you'll see on the moisture. It could be a situation where your module is out of calibration. That's something to also check. And what else? I think that's about it on the moisture. Contacting us if you do, run a test on a breaker or on a bottle of gas that is really dry and it's testing way higher than you think. Reach out to us. We can help you get that module replaced if there's an issue. We can't control always all the variables that are associated with the individual sensors. So the other one we hear most commonly is on the SF₆ percentage. Hey, my SF₆ percentage is reading a lot lower than I expect. A lot of the same troubleshooting functions that we just talked about. So that'd be checking for leaks, running the evacuate hose to make sure that your hose isn't leaking, tightening down all your different modules, really just checking to make sure that the system, everything that the gas touches up until the sensor, is leak checked and is tight and isn't contaminating with any like outside air or anything. And then also too, obviously too, with the gas that you're testing, do you know for sure that it's pure? Has it been verified? Before you actually, start going down the rabbit hole, you need to have a benchmark of gas that you're using to test these things. So those are some things you should test first, along with calibrations, of course. And then, of course, we have firmware and bugs. This is synonymous with any gas analysis equipment. Sometimes there is bugs that are found by customers out in the field that we haven't found yet, and we need to do a quick firmware update for you. I would most of the time reach out to us to help get those resolved. Sometimes it's as easy as turning the device on and off, power cycling, and then see if it's still persists. And if not, or if it does, then reaching out to us and saying, hey, here's what's going on. Give us the firmware number that you're dealing with, and we can kind of help steer you in the right direction. Um, we've periodically improved the firmware as we found different things and added things that made more sense to the unit over the years. So if you have an older unit, Siri is freaking out. If you have an older version of a device that you need to get updated, reach out to us. We can help you get that updated. And that's about it. Pretty easy to do the firmware update. You can just plug that USB stick in and get that updated. Let's look at some of the questions that have come through. I know we're about 45 minutes in, so I want to be cognizant of the time. Let's check. Oh, wow. Decent amount of questions here. So, lowest pressure that the test set can measure. Justin answered that, 5 psig. Condition on the flex. Okay, looks like all these are already answered. Probably don't want to spend too much time on this. We can probably wrap things up here. So if you guys have more questions, have questions about the device or just gas testing in general, this is a pretty quick and dirty on refresh how to use an analyzer and how to test gas. We have more training that we can come out and do for you, or we have an online class that goes in a little bit more detail on some of the chemistry and backgrounds and all the contaminants and stuff to look for that you can access for free. If you want to check that out, let us know. And again, we really appreciate you guys all being on here, taking the time out of your day to check this out and get some training. So unless we have anything else that came through on the chat. Oh, okay. Actually, one good thing, the reminders on the sensors. So we do have a system set up to remind you of when to replace your sensor modules. For us, we have frequencies of about a year or every 2 years, depending on which sensor module you're talking about. And I can actually show you what it looks like, because I didn't do that yet, to swap a sensor module. So let me go back to our... So on the SO2 sensor, we're going to swap this out. You can see on the screen, it's showing selected and it's enabled. So we're going to pop this out. We've got our torque wrench, unscrew both sides of the sensor module. And then once we get those loosened, we can pull up the sensor module from those screws. So we've got both of them loosened on either side. You can kind of see how those are popped up. We're going to grab both screws and pull up, pull straight out. That kind of pops out. It feels like an Atari cartridge or a printer cartridge. So we'll get that one swapped out for a new one. And you can see on the screen now that module has disappeared because it's no longer connected. So we're going to pop in the new one, and you'll see there's a power light that comes on when that actually is connected. And we'll start tightening down these screws. You'll see it auto-populate on the screen knowing that it's connected. And we'll get this torque wrench on it on either side. Tighten those down. You'll hear that click for the torque wrench once it's up to the right torque, and you're good to go. And all that, again, all that calibration data is automatically populated in the modules area in the settings. So, okay. Yeah, I'm going to go ahead and wrap it up here, guys. Again, we really appreciate you guys hanging out with us today. I'm going to put the title screen back up just in case there's some more questions coming through. But for now, again, really appreciate y'all taking the time, and we'll see you again on the next one.